All right. Good evening for everyone who is watching this. Welcome to the monthly meetup of the Azure DevOps user group Sri Lanka. My name is Malin De Silva, and I'm located in Netherlands, and I'm VP for Microsoft Azure. And today we are going to have a brief introduction to Azure Batch. The idea is to discuss the concepts, why it is needed, and what are the features that are available within Azure Batch to be consumed. All right. So, if you are just a little bit new, depending on the audience, just to understand what is a batch job. Back in the day, the servers were very slim in size, so it's not easy to process quite a lot of large volumes of data. So the idea is to let things run the business as usual during the day and then run the highly processing compute consuming things at the night. Usually this is because of a few reasons. Most of the time the data were in a single database. We were using the monolith application structures, so there was no way of separating and evolving databases and things like that, compared to what the distributed compute applications that we are designing today. Usually it involves quite a lot of large data sets. Let's think about a bank and imagine you want to calculate the interest of for a particular day. So if you do calculate interest for a particular day, if you think about a million customers, that means you have to consider 1 million record at least. And then there can be data sources coming from here and there, so it can be a little bit disturbing for the daily normal transactions that are like such settlements and things like that are going on to be executed, and they can be disturbed. Maybe database can go offline. If that happens, certain challenges come in there. But at night it's calm. Banks usually close at 4 p.m. And then thereafter you can execute it very easily. That's in the context of Sri Lanka. Most of the countries assuming the online banking wasn't the case, but now the online banking was there is there. But even though still, the transactions after midnight are very low, so something like this can easily be performed without affecting the core systems there. And then certainly most of the bad jobs, they require longer processing. So it's not like you're updating a single field. You might have to look up different tables, maybe calling external API calls to get some. Maybe if you look at some sort of a bank example, to get the foreign currency exchange rates, you might have to call a different API from different external system or cache version of the local system that is in there. So there are quite a lot of transactions that you steps that are involved, and they are costly in terms of the processing. That's the reason why bad jobs were there. And then, as I earlier said, these are not business critical. In case of interest calculation, if the interest are paid on the next day, it's enough that it is calculated at midnight. So whenever, unless there is a significant amount, usually these things are anyways automated. For example, if you have like $1,000 and on 2% interest rate, that is due by tomorrow morning, the bank will be automatically calculated. There are certain workflows and exceptions, but in the general cases, these do not need to be real time things. Now, that is what a batch job used to be, and currently the concepts are quite same, but unlike the days before, if you look at the options we had, if you are running on a Linux operating system, you could use cron jobs, and if you are running on a Windows server, you had the Windows task schedulers that will trigger at night, can run quite a long time. Maybe someone who is monitoring the process in the background, but overall it's a very easy thing to do. But now things have evolved. making a decision on using a compute service has become a lot complicated. And here I'm referring to the Microsoft Cloud Computation Decision Tree. This is available on Microsoft page. You can just Google it, like Cloud Computation Decision Tree. So if you look at a application, and if you want to full control, usually you put it in a virtual machine. But the reality is right now, a lot of this is more like infrastructure as a service, so a lot of organizations are not promoting it. It's not really necessary. And then if not, if it is a high performance control workload, the idea is to go to Azure Batch. Uh, that gives you can run this process for like hours without uh, consuming, without worrying about the core compute systems that are in the websites or the databases. If you have the data scaling and data layer managed. But other than that, there are quite a lot of other options available within Azure Functions as well. For smaller jobs, you can run cron jobs. These are called, you can have schedulers there, and then something that was available with the Windows uh, app services. Azure App Services on Windows was the Azure Web Job, which is like something you can do, very simple thing related to that particular Azure website. You can run a web job and get that done. But now, out of all these things, you can see the segregation happens at the top. If there is high performance workload, ideal way would be the Azure Batch to execute, because it has quite a lot of features, and that's some of this we will be discussing now. Right. Now, what are the features? I'm not going to duplicate the content on my slide deck, so just I'm going to refer to the Microsoft documentation itself. It's highly scalable. Imagine if you have multiple jobs need to be run, and you cannot occupy a single machine there, so you might need to distribute your processes. If your application can be distributed like that architecture wise, yes, you can scale into multiple virtual machines. It does not default allow you to go to hundreds or thousands. There are ways to do that, but ideally, but if you need, you have the option to do that. It's more like having a discussion with Microsoft first hand, and then you can stage data and execute compute pipelines. So data pipelines are coming to cloud most of the time, and they contain millions or billions of records. Processing them in normal compute nodes is not effective. So the batch is the ideal way to execute. It's maybe something like Azure Data Factory or something like that. You can run on Azure batch compute nodes there, and then you can auto scale. So if you have multiple execution requirements, you can distribute it across different pools and scale them accordingly. Basically, that's it. And then you have the option to pick between Windows or Linux. Usually, now most of the applications are running on Linux because it's free of license cost, and it's far highly executable for the server workloads at least, and it's very easy. And then the other thing is you are paying to what you use. So you don't, if you look at something like a website, you don't need to keep the website up. You have to keep the website up. Yes, you can scale down some things, but you have to keep the website up all the time, because if one user comes in, that user needs to be having access to web. But here it is not. You can, if your workloads are taking only 2 hours out of the 24 hours, you can execute that web itself for just 2 hours out of the 24 hours. So you're only paying for that 2 hours. I will show how. Basically, that's it's easy like that. Yeah, so these are like the core features. We will know a little bit more when we go to the portal and see the demo itself very easily. Right. Yes. Now, we are coming to the a few important concepts to understand the Azure Batch. These are like the foundations how the it's architectured across Azure Batch. So starting off an application. Now, what is an application? It can be something like console application, .NET console application that you build to change a field or calculate the interest, as I said. So likewise, those applications can be hosted on Azure Batch. And the good thing is you can maintain multiple versions of that applications, and when you are executing you can specify the version that it needs to be executions. For example, if you have two versions, version 1 and 2, and if you think version 2 is not the right thing, you can easily roll back to version 1. Or if you see something going wrong with version 2 and it's something new that you are providing right now, if it is need to be tested on live production, you can do it and run version 1 both at the time. So it depends on how you architecture the application reality. The second concept is pool. Usually the concept of pool is quite similar across all the Azure concepts. Basically it's I have said it like zero to many compute resources of the same class. So what happen is when you're executing, you might be leveraging one or two or three, maybe four worker nodes for the compute process. So in that case, all these are assigned into a single pool. You can make the pool zero, or you can make the pool one or two, or go whatever to up, as long as Azure allows it. There are restrictions. I will talk about it, but you can basically scale it up. And then we have tasks. A task is like we have the application here, so you can run that application, and running that application is like a single task. That's basically the smallest unit of execution, just like a mole in chemistry. Yeah. And then you have jobs. A job is like a collection of tasks. You can have multiple jobs. uh, you can have, even you can have tasks running multiple jobs, or it can be vice versa. But basically a job gets associated with a pool and then execute the task. So if you have four nodes and you run a single job, you can make the four jobs run in four different computers on the compute resources, rather than just waiting for one to finish, the other one goes in. So that thing can be easily configured. And then the last one is the job schedule. So if you have a job that you need to nightly execute, you don't need to do it manually. So you have the freedom of scheduling it. It's very easy. You can configure the setup. There are templates that allow to automate the process as well. So you just can watch it execute and see the results in very easily. That's basically the idea. These are the core concepts, but around these, the normal Azure concepts that come in will come up. The authentication, networking, logging, monitoring, all these concepts, and DevOps connectivity, everything just comes in. It's no exception. It's much familiar. If you are using any of the other Azure services, it's very easy to get started with the Azure Batch. Right. Okay. Now I said about something like pool being a zero to many compute resources. Now I have created some application scenario where we need to run some application on demand but random. It can be a case of you have multiple workflows and you need to execute it during a particular time of the day, or on a demand certain based on certain things. Situations like this are also supported because Azure Batch has a SDK. I designed one recently, and it was following the following flow. Basically, you have an Azure function, and it can make up the pool. So the pool will scale from 0 to 1, and then you can schedule a job there. So once you schedule the job gets creates a job once the VMs are up, and assign the task depending on how you schedule it. And once it is executed, the job will terminate and decouple. That's sort of a option that is available. It doesn't mean you have to do it that way, but this is one of the scenarios because it was on demand random scenario. It's not you cannot schedule it with a job schedule. It's random. If you want to keep it a very clean nightly schedule, you have the option here for the job schedule. Otherwise, something like this easily integratable with the SDK and the APIs that are available for the management plane of it. All right, let's go to a small demonstration on how this is done. I will just start with creating a resource. I will not be using that one, but I will show you how it works. Now, I will just search batch. It gives me quite a few options. Let's see how many comes in. Yeah, so as you can see, there are multiple options coming in here. For example, you have Azure Batch rendering or batch service, or quite a few other batch AI service, or it's retired, and quite a few other options out here for the batch process. But I'm going with the Microsoft template for batch service. I can create. This is very basic. You can select the resource group and demo. And okay, I have already one. I'll pick somewhere else. And demo 1 in 2, something like that. And then I will go to next. So basically, it will allocate the how the identity is happening is that it's system assigned or user assigned. So this will be helpful in future when we are doing the authentication. I think we can change this very easily after that, after the creation as well. And then it asks the pool allocation mode. How it works is you can allocate. So as a user can have access to a set of node pools, as well as the batch service can be having it there. And the next one is the authentication, Microsoft Entra ID, shared key, task authentication token. You can select. Usually the shared keys are not in use in the modern ways, but usually the Entra ID is the more standard way of using. Then you have the networking options. So not everyone will be able to access batch, as well as the batch services won't be able to access public internet if you restrict it. So basically, those are the features available. Now, if I create this, it will take a bit of time to create it. The advantage is these are restricted by the region depending on the quotas available. But if you create a badge account, it does not charge you anything for any of it, because if it gets charged when you add pools into this. Now I am getting here to one of the example batch accounts that I have created. It's in West Europe. I have all the resources here. So let's go through some of the concepts that we have. Now I will go with this quotas settings here. You can see the other access control and everything is there. Basically what we have is Azure Batch service by default comes in with certain restrictions. Why is that? Because in the way how Azure Batch works is whenever you need, you can get a VM assigned to you. So that's sort of on demand. In order to do that, Microsoft has to maintain a set of pool of resources in the backend. So if you suddenly demand like 1,000 VMs, they might not have it in a particular region. So that's a bit monitored in the backend. But you always have the option for requesting a quota increase. It will be like a support request. And if you do it, you should be able to manage this with them. It's just a priority. So what we have as restrictions: active jobs and schedules. So you can have run 100 jobs actively and concurrently, and you can create up to 20 pools per batch account, right? And batch accounts per region, per subscription. That's what we see when we are creating the previous one. It's just one. So if you increase it, you can create more. Ideally, if you want to go with the your organization developer life cycle, it's like dev, test, pre-prod, prod. So you will need 4 out there, unless you plan the architecture the solution different way. And then we have the option called spot or low priority virtual CPUs. So what is this? Azure Batch supports two types of virtual CPUs. Now we are talking about virtual CPUs because these are CPUs are virtual. It's not physical CPUs. Spot or low priority means the spot vCPUs can be, these are like the low priority ones. These are sometimes these are like leftovers from the other node pools. You can take them. So these are not like dedicated for you. These are kept away. But on the other hand, these are much cheaper. You can learn more and read about it. Most of the times, regulated industries don't use them. So it's because of the security concerns out there. But it's not a major security concern. It's just a regulation thing. But on the other hand, we have the total dedicated vCPUs, and they come in like different sizes, as you can see. Quite a lot of them have zeros, and if I sort it here, I have like 5 classes. There are VM series that I can have up to 6 vCPUs here. Right. So these are the ones that I can do it. If you need something else for different reasons, because if you look at DV3, it's more like the general version that you use, DSV3 or DV3, and A series is like the previous ones. The others are, I'm not quite sure. Basically, you have what you need for a general one, and always you have the option for requesting quarter increase, things like that. So as you can see, multiple options are already there, about 5, and if you need many more, you can have it here. Yeah. All right, next let's go to the concept of applications. We are not going to use applications in this demo, but what will happen is usually if you need a console application or something to be put in, you can easily add it here. I usually use Azure DevOps to do this. The pipeline's created and then you can easily deploy it. But if not, you can have a defined application ID, a version for it, and select application package in here. So how does it work is if you go here, you have the storage account. Right now I haven't associated storage account with this batch account. What will happen is you can associate a storage account with the batch account, then all the applications will go to that storage account. So it will be in storage account folders every version you upload. So whenever it's need to execute, this will take the application from the storage account to the compute working directory and execute them and shut down. That's basically the idea. So you can put up 200 applications here, but I think you can increase it if you need. Ideally, most organizations can escape with 200. It's not a big thing, and it shows here the warning that I don't have a batch account configured for this. So if you go here straight away, you can set up a configure one. Next one is pool. I have created a pool already, and if I go here, it has a pool ID and the dedicated nodes, spot low priority nodes, current vCPUs, and the VM size. As I said, D2S, D3, and the state is ready. Now, if I need, I can what I can do is you can see one node is idle here. I can scale it up to 2 nodes. I can put 2 and scale it up if I need. So what will happen is it will add more nodes to it. It has 2 vCPUs because single node support like 2 vCPUs. Likewise, so the resize option can have here, right? But for this demo, one pool is enough and one node is quite enough to showcase what I'm going to do. But I will show you scaling after everything's done later. The next thing is job. A job can have different status. I will add a job here. First, let me go here, go to the jobs and create a new job saying job 2, and then I can select a pool. and I will set the only available pool here. If you have more, you can add them, and also you can add some job manager tasks. So before preparing the job, you can do these things. For example, if you want to execute some data workload, and if the database need to be scaled up, and if there is a process to do that, you can do that here. So, and then you have all the other configurations, priority, and what to happen after the task completed. You can have the no act, terminate the job. Basically, that's it. So different options are there. You can set up environment variables. Quite a few things are there. But I will not create one. I will go back to the one that I already have because it's still running. It's fine. So if I go to the overview, you can see a summary of things. Two tasks have succeeded and one has failed. Let's go to the task to see what has happened here. So if I come in here, I have task 1 that succeeded and this has failed. Okay. So if I go to the failed one first, as you can see, it has been active, running, and completed and failed about an hour ago. So if I go more further, I can see much more error. If this application, you can see the application logs usually. But the idea is if it's failed, you can see all the logs here. Now let me create something new. I'll create another task. I will call this task 4. It's pretty simple. If you need, you can set up a display name, but I don't need. I don't think I can duplicate it in the same one. Maybe I'm wrong. So what I have is a Linux worker pool. If I go back to my pools, so if I go here, you can see the OS. Where is the OS? See, it's a CentOS container what we have right now. So it's a Linux sort of a OS. It's not Windows. So I have to use the Ubuntu or Linux syntax, whatever that's in there. So what I will do is something pretty simple. I will create tasks 4, and then I will do a print line. I will say hello task 4. It's a simple thing. Ideally, if you have a application, you can run a command here to execute that application in this version. That's basically it. And when you're running a task, you can have multiple options. As you can see, enabling authentication token, and how much clock time you get, how many retry attempts, how much retention. It's like days. How many days you need to retain this task. Require slots and elevation level. Whether this needs some sort of a admin user for the task or a pool admin level. So these are required. Those permissions are evaluated here. And then certain resource files. If you want some images to be referred from the storage account, you have to specify this. It looks a little bit difficult here because we are doing this manually. Usually once this is automated, it becomes a very easy thing. It automatically picks up things. And then you can set up the environment settings. You can have key value pairs of the configuration here. And then the dependencies, if you have multiple dependencies on the task, you can specify here, but it's not enabled on this job, so that's why we cannot do that. And then lastly, the application packages. Right now we don't have any application packages, that's why it's coming here. So you can specify that. You specify that and give an execution command here, then it will execute the application. That's basically the idea. Right. So right now what we have is, it's more like a hello world program of console application. What we'll do is it will say hello task 4. Hopefully it will say it. Let's submit this. Right. Now task 4 is in active state. If you go inside, you can see active, preparing, running, and completed states. I will refresh this screen a little bit, and it has completed. If I take it up a little bit. You can see how much time it taken. Refresh a bit. Yeah, it's all good, I think. So it shows the pool that is associated and the node within that particular pool. So a pool can have multiple nodes, and as you can see, this one has this node and it has multiple folders here. If you have the applications from the storage accounts, it will come to this before executing, and the startup and the work items related to job one. As you can see, everything is here at the pool level. And if I go to the task inside itself, here also you have a working directory here, WD. If you want to put some text or something like that, you can put it here. And the error file is empty here. What we'll see is whether the error file has in the errored ones. Yeah, so the one that failed has an error like this, cannot execute binary file. But if we go to the one that we just created and executed, and it has the output file, it says hello task 4. So basically it gets printed. So if you are writing an application and it has a lot of logging in the application sides, and you need to do some logging to the console as well, you can have them all in here. Basically, once you need to troubleshoot, you can just go here, or you can download and request this one from the support team. Yeah, so that's basically it. What I want to cover today. You have all the other options like environment settings, metadata, all these things. Now the job is done here. So what I'm going to do is I will terminate this job and just terminate here, and you can actually set it to automate as well. So if I go here, this job shows like completed. Now if I go to pool, I can pick from here. I have two vCPUs running and one dedicated node. That means it's costing me. I don't plan to do any other demos or anything like that, so I can set this nodes to 0. Let me see how it works. Now it goes to resizing cycling pool. If I go to the overview and refresh this, as you can see, it says resizing. Just go here, you can see the pools. See, it's coming from 1 to 0, and the status is resizing. Let's see how it goes here. So what happens is, ideally the available node here will be become unavailable. That's basically what's going to happen. It might take a few times because there are certain connections and configurations associated. You need to kill them all and allocate it from here. But as you can see, it became green, so which means it's now leaving the pool. Okay, let me refresh it a bit again. It should disappear, so it should become 0 here in a few seconds maybe. Yeah, so it's still in the leaving pool state. Might be in a few seconds it will go away. Just see a few seconds. Yeah. It will take a minute or two to do it, but basically that's what's happening. You can see, you can, the same way you can add them to the pool. If you add them to the pool, they will get to here, like creating and so on. Basically goes there. Right, so that's it from me for this session. Thank you so much for joining in. If you have any questions, I'm on Twitter as well as on email. You can contact me. This is my Twitter tag. Feel free to ask any questions. Over there, I will be available to happy to reply over there. All right. Okay, then thank you so much for joining in today. Hope you have a great day. See you.